Hi, today we'll be taking a look at population density and distribution. I just want to bring your attention to the fact that some of the slides in this video are going to be missing words which I will be saying out loud. And the idea behind this is that you really should be listening to these videos and not putting them on silent and just copying the words down into your notes. Okay, so let's take a look at population density and distribution. So if you remember from the previous chapter, a population is a group of organisms of the same species that live together in one place and they interbreed or mate with each other. So here is an example of some sea turtles that are all in the same population. Population density is the number of individuals that live in a defined area. So this is a population density map of the United States. You can see here, lighter colors indicate low population density in states like Alaska, for example, and Maine. And dark colors indicate high population density in states like California, for example. You want to think of population density as, in simple terms, how crowded an area is, how many individuals are crammed into one space. So on this map, you can see that the most densely populated state is right here, New Jersey. That is us. And you can definitely feel that high population density on Fridays when you're trying to get somewhere in traffic, or if you try to go to the mall on a Friday night and you see all those human beings in the same place. We are a very densely populated state. Bergen County being actually one of the most densely populated counties in New Jersey. Okay, so how is that population density calculated? And population density is calculated as follows. Basically, you count the number of individuals and you divide it by the area, which is in units squared, typically in kilometers squared. So let's say that a scientist is out in the field and she counts 200 narwhals. These are the narwhals over here, right, with that long tusk living in the north in Arctic waters. So let's say she's out there freezing on a boat and she counts 200 narwhals in a 10 square kilometer area. The way she would calculate population density is 200 narwhals divided by the area that she was looking at, which is 10 kilometers squared, and she would calculate a population density of 20 narwhals per square kilometer. Geographic dispersion. How individuals in a population are spaced is what is known as geographic dispersion. Population dispersion is the way in which individuals of a population are spread in an area or volume. Population dispersion comes in three flavors. It can be clumped, uniform, or randomly dispersed. And these are the images of each. This is clumped dispersion, where individuals are in these groups or clumps. This is uniform dispersion, where the individuals in a population are spaced uniformly and evenly. And this is random, where the individuals are kind of randomly dispersed. And we'll take a look at each one of these. So right here is clumped dispersion. Fish tend to clump. They swim in schools, and you can find different schools in different areas of an ecosystem, but they are typically in clumps. It's not like the fish are swimming off by themselves in a random distribution. They really are in clumps. Individuals live close together in groups for several reasons. It can include protection, as it is in the case of the fish, to facilitate mating or to access food supplies. The second type is uniform dispersion, and you can see it really well with these nesting birds. They are evenly distributed. Each one has its own territory, and it doesn't infringe on its partner or mate's or neighbor's territory, rather. This is territoriality and interspecies competition for a limited resource, and it can lead to individuals living at specific distances from each other. The third type of distribution or dispersion is random. And in random dispersion, individuals are randomly distributed. So for example, you can see these dandelions outside, and some of them are in groups and some of them are by themselves. They don't follow any type of pattern. That's called random dispersion. Over here is the sloth, taking it really easy, having a nice day. And sloths tend to be randomly dispersed in their environment. They don't clump in groups, and they're not evenly spaced either. So survivorship curves. A survivorship curve is a diagram that shows the number of surviving members over time from a measured set of births. This helps to describe the reproductive strategy of a species. Here are some survivorship data. So you can see the age groups in this left-hand column: 0 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25. Here are some death rates, and then we're calculating survivors here. And then percentages for how many individuals survive. So in the 0 to 5 age group, 97% of the individuals survive, which is high. And in the 21 to 25 year age group, it's only 80% that survive. Okay? So we're going to look at what a survivorship curve looks like next. And here it is. And you can see 3 lines here: the orange, the green, and the blue. And they indicate 3 types of survivorship. There's type 1, type 2, and type 3, and we're going to take a look at each of these. So the first type is type 1, and type 1 can be seen in orange. And what happens in a type 1 survivorship is that early in the lifespan, individuals will tend to survive, and after old age, that population will decline rapidly. So this is common among mammals. And type 1 individuals have a low infant mortality. They survive to old age, and the parents tend to care for the young. So an example would be humans in this category. So there you can see me dressed up as a koala bear, of course, with my baby. And I can tell you firsthand that little babies need a lot of parental care. They need to be taken care of for a long time. And luckily, since we are a type 1 survival species, infants tend to survive their childhood because of all that care from their parents. And they survive for a long time, and that survivorship only drops off after old age. Type 2 survivorship can be seen over here. And in type 2 survivorship, this is common among birds, small mammals, and some reptiles. In type 2 survivorship, there is roughly equal survival at all ages of an organism's life. So this green line shows you type 2 survival. And you can see that no matter what stage of its life this organism is in, it has the same chance of surviving, whether it's young or old. There's really no difference in survival rates. Okay? And the third type of survivorship curve is type 3, and this is very common in invertebrates, fish, amphibians, and plants. In this scenario, there's a very, very high birth rate and a high infant mortality rate. So you can see here, very, very, very often individuals die. There's a huge number of individuals, and a lot of them die, and once they make it through that early life stage, then they end up surviving. So an example of this type would be the sea turtles we saw in the beginning, right? Sea turtles will lay their eggs, and thousands of baby sea turtles will hatch, and they will all try to make their way to the ocean. As they do, though, many of them are going to be picked off by different types of predators because baby sea turtles are very, very vulnerable. They have no defenses. And basically, the small number of baby sea turtles that survive and get to be larger and older, once they're larger, then they tend to survive. Okay, so here is an example of that third type of type 3 survivorship. This is on Christmas Island, and what you're seeing here is not insects. These are tiny baby crabs, all really hatched at the same time. And it's like a huge tourist attraction. People come in each year and they observe these crabs crabs coming, laying eggs. These are the adult crabs, and then all the baby crabs here that are hatching at the same time. Now, most of them, unfortunately, are going to die. But when they survive to be larger, once they're bigger, then they're good. Then they're going to make it to old age.